Artificial intelligence feels invisible. It exists inside applications, inside conversations, inside recommendation systems, inside search engines, inside autonomous software. Most people imagine AI as code, algorithms, mathematics, something that exists somewhere inside the cloud. But the cloud has an address. Every response generated by an AI model eventually reaches a physical building. A building filled with processors, power cables, cooling systems, fiber optics, transformers, backup generators, and enough infrastructure to support one of the most computationally intensive industries humanity has ever created. These buildings are data centers, but calling them data centers no longer captures their true purpose. They have become factories. Factories that no longer manufacture steel, cars, or consumer goods. They manufacture computation. Every second, electricity enters, information leaves. Inside these facilities, power becomes intelligence, silicon becomes prediction, and computation becomes one of the world's most valuable economic resources. The AI revolution did not eliminate industry. It created an entirely new one. An industry measured not by smokestacks, but by megawatts, not by assembly lines, but by GPU clusters, not by physical products, but by the ability to generate intelligence at planetary scale. The future of AI is not floating in the cloud. It is standing inside buildings larger than aircraft hangars. Because before intelligence becomes software, it must first become infrastructure.
The first generation of data centers served a relatively simple purpose: store websites, host applications, deliver emails, process business software. The workload was predictable. The infrastructure expanded steadily. Then cloud computing arrived. Instead of buying servers, businesses rented computation. Infrastructure became a service. Scale became an advantage. The largest providers built increasingly larger facilities, hundreds of thousands of servers, global fiber connectivity, highly automated operations. The cloud changed the economics of computing. But artificial intelligence changed something even bigger. It changed the physics. Training advanced AI models requires extraordinary computational density. Thousands of specialized processors operate simultaneously. Massive quantities of electricity flow continuously. Heat accumulates at unprecedented levels. Entire facilities must be redesigned. The modern AI data center is no longer simply storing information. It is performing industrial-scale computation every second. The warehouse became a factory. Its production line is invisible. Its output is intelligence. And like every industrial revolution before it, the organizations capable of building the largest factories gained extraordinary advantages. Scale lowers cost. Scale improves efficiency. Scale attracts customers. And scale compounds over time. The cloud was once an IT service. Today, it has become one of the most strategically important industrial sectors in the global economy.
Every industrial age has been defined by its primary resource. The steam age depended on coal. The automotive age depended on oil. The digital age depended on silicon. The age of artificial intelligence depends on electricity, not simply because computers require power, but because computation itself has become an industrial process. Every AI response consumes computational resources. Every model update requires processing. Every recommendation, every translation, every generated image, every automated decision begins with electricity. Electricity powers processors. Processors execute calculations. Calculations become intelligence. The transformation appears abstract,
yet physically it resembles manufacturing. Raw energy enters a controlled environment. Machines perform specialized work. Heat is generated. Outputs emerge. The product simply happens to be digital. This changes the economics of energy. Electricity is no longer only powering homes, factories, or transportation. It is increasingly powering intelligence itself. Countries once competed for oil fields. Tomorrow, they may compete for electrical capacity capable of sustaining hyperscale computation. The next generation of economic power may belong not only to those who build the best algorithms, but to those who can reliably transform enormous quantities of energy into computation. Because intelligence is no longer only created by people, it is increasingly manufactured by infrastructure.
For centuries, economic power was measured by land, then by factories, then by oil. Today, a new metric is emerging: compute. Not simply processors, not simply servers, but the total capacity to perform intelligence at scale. Every advanced AI model competes for the same resource: computational time. Training a frontier model requires enormous clusters operating continuously. Inference requires thousands of processors responding instantly to millions of users. Scientific simulations demand compute. Drug discovery demands compute. Autonomous vehicles demand compute. National defense increasingly demands compute. The question is no longer who owns the smartest engineers. It is becoming who owns the largest computational infrastructure. This changes the balance of technological power. Companies capable of deploying vast compute clusters can develop larger models, run more experiments, serve more customers, improve faster. Scale becomes a competitive advantage, and competitive advantage compounds into market leadership. The AI race is therefore not only an algorithm race, it is an infrastructure race, an energy race, a semiconductor race, a capital expenditure race. Behind every breakthrough model, there is an invisible mountain of computation, and whoever controls that mountain shapes the pace of innovation for everyone building above it.
Every calculation produces heat. One processor generates a small amount. Thousands generate more. Hundreds of thousands create an engineering challenge unlike anything previous generations of data centers experienced. Heat is the hidden enemy of computation. Too much heat reduces efficiency, damages hardware, limits performance, and increases operational cost. This is why modern AI facilities increasingly resemble power stations. Gigantic cooling systems circulate enormous volumes of air or liquid. Heat exchangers operate continuously. Pumps, cooling loops, thermal monitoring, environmental control. Everything exists to maintain stable operating conditions. In many facilities, cooling infrastructure occupies nearly as much engineering attention as the computing hardware itself. Because the objective is not merely to install more processors, it is to keep every processor operating at peak efficiency. The AI revolution therefore depends on a discipline rarely discussed outside engineering: thermal architecture, the ability to move heat away from computation. Every improvement in cooling increases usable compute. Every increase in usable compute improves productivity. And every productivity gain compounds across millions of AI requests every hour. The world's most advanced intelligence factories are therefore also among the world's most sophisticated heat management systems. Before artificial intelligence can answer a question, someone must first solve the physics.
Digital technology appears borderless. Data moves globally. Applications reach billions. Artificial intelligence serves users everywhere. Yet the infrastructure behind it remains profoundly physical. Building a hyperscale AI campus requires far more than available land. Reliable electricity, high-capacity transmission networks, low-latency fiber connectivity, water or advanced cooling solutions, political stability, engineering talent, construction expertise, long-term capital, all must converge in one location. This creates a new geography of computation. Some regions naturally become attractive because energy is abundant, others because connectivity is exceptional, some because governments encourage investment, others because they already possess mature digital ecosystems. Location becomes strategy. Once a hyperscale campus is built, additional investment often follows. Cloud providers expand, telecommunications improve, businesses relocate, specialized suppliers emerge. The ecosystem begins reinforcing itself. Infrastructure attracts infrastructure, talent attracts talent, capital attracts capital. This is the same economic pattern that once created industrial cities, except today's industrial districts manufacture intelligence instead of steel. The digital economy never escaped geography. It simply replaced ports and railroads with fiber optics and power grids. And in the age of artificial intelligence, the most valuable locations may be those capable of delivering uninterrupted computation at unprecedented scale. Building one data center is expensive. Building hundreds changes the economics entirely. Every hyperscale operator faces extraordinary upfront investment. Land, construction, electrical infrastructure, cooling systems, networking, security, hardware, engineering. The numbers reach into the billions. But once the infrastructure exists, something remarkable begins to happen. Every additional customer increases utilization. Higher utilization spreads fixed costs across more workloads. Lower costs attract more customers. More customers justify larger facilities. Larger facilities negotiate better hardware contracts. Better pricing enables further expansion. Expansion attracts software ecosystems, and software ecosystems attract developers. This is no longer a simple business. It is a compounding system. Infrastructure generates efficiency. Efficiency generates adoption. Adoption generates revenue. Revenue finances even larger infrastructure. The cycle reinforces itself. This is why hyperscalers are difficult to challenge. A competitor is not merely competing against software. It is competing against decades of accumulated infrastructure, decades of engineering knowledge, operational experience, supply chain relationships, global connectivity, and capital deployed at extraordinary scale. The true competitive advantage is not a building. It is an ecosystem built around thousands of buildings operating as one coordinated machine. The modern economic moat is no longer always protected by patents. Sometimes it is protected by infrastructure that is simply too expensive, too complex, and too interconnected to reproduce quickly.
For decades, electrical grids were designed around familiar patterns. Cities woke up, factories operated, homes consumed electricity. Demand rose and fell predictably. Artificial intelligence is changing that equation. Hyperscale computation requires continuous power, not only during business hours, not only during periods of peak demand, but every hour, every day, every season. Training a frontier AI model cannot simply pause because electricity becomes expensive. Inference infrastructure cannot disconnect because millions of users expect immediate responses. Computation demands stability, and stability demands resilient energy systems. This creates a new relationship between technology companies and energy infrastructure. Power generation becomes a strategic discussion. transmission capacity becomes an economic constraint. Grid modernization becomes part of digital transformation. The future of artificial intelligence may therefore depend as much on electrical engineering as on software engineering. As nations compete to expand AI capabilities, they are also competing to expand the infrastructure capable of sustaining those capabilities. The next generation of technological leadership may be determined by a simple question: who can deliver reliable electricity at unprecedented scale to the factories producing intelligence? Because every AI breakthrough begins long before the algorithm. It begins the moment electricity enters the building.
Every technological revolution reorganizes power. The Industrial Revolution rewarded nations that mastered manufacturing. The Oil Age rewarded those controlling energy. The Internet Age rewarded those connecting information. The Intelligence Age is beginning to reward those who control computation. Artificial intelligence does not emerge equally across the world. It concentrates where infrastructure exists, where electricity is abundant, where fiber networks converge, where semiconductor supply chains remain reliable, where capital can finance billion-dollar facilities, where engineering talent continues to expand. Compute is becoming geography. The map of intelligence is increasingly determined by the map of infrastructure. This creates a powerful feedback loop. Regions with more computation attract more AI companies. More AI companies attract more researchers. More researchers create better models. Better models generate more investment. Investment finances larger data centers. Larger data centers create even more computational capacity. The cycle accelerates. This is not merely economic concentration. It is infrastructural concentration. The organizations controlling the largest compute ecosystems gradually become indispensable to thousands of businesses building on top of them. Startups, universities, governments, healthcare, manufacturing, finance, defense, scientific research. Entire industries increasingly depend on computational infrastructure they do not own. This is one of the defining shifts of the 21st century. Previous generations competed for natural resources. The next generation may compete for artificial intelligence infrastructure, not because intelligence itself is scarce, but because the infrastructure required to manufacture it demands extraordinary scale. And scale has always concentrated power.
History rarely remembers infrastructure while it is being built. Roman roads were once ordinary construction projects. Electrical grids were once engineering experiments. Railroads were once expensive investments. The internet itself was once considered a niche technology. Only later did civilization recognize that these systems had quietly reshaped the world. Artificial intelligence may follow the same path. The headlines celebrate new models, new applications, new breakthroughs. But beneath every breakthrough, a far larger transformation is taking place: the construction of an entirely new industrial foundation. Data centers are no longer supporting technology. Technology is increasingly supporting civilization. Healthcare depends upon computation. Finance depends upon computation. Scientific discovery depends upon computation. Manufacturing depends upon computation. Education, transportation, national security, communications, energy optimization, every sector is becoming computational. The true product of an AI data center is therefore not simply intelligence, it is capability. The capability to solve problems faster, to optimize systems continuously, to accelerate innovation across every industry connected to it. This is why the world's largest technology companies continue investing billions into infrastructure that most people will never see, because they understand a principle that has repeated throughout history. The greatest fortunes are rarely built on the products everyone notices. They are built on the infrastructure that every product eventually depends upon.
That is the hidden architecture of the AI economy. Algorithms may capture attention, applications may capture users, but infrastructure captures dependence. And dependence is one of the most durable forms of economic power ever created. The next industrial revolution will not be remembered only for the intelligence that machines achieved. It will be remembered for the civilization that humanity built around that intelligence. A civilization powered by electricity, connected by fiber, accelerated by silicon, and manufactured inside colossal factories transforming energy into computation. Because the cloud was never a cloud. It was always a machine growing larger with every prompt, every model, every breakthrough, and every decision to build another factory of intelligence. The future will not belong solely to those who create the smartest artificial intelligence. It will increasingly belong to those who own the infrastructure capable of producing intelligence at planetary scale. Because in every era, power follows infrastructure, and infrastructure always begins long before the world realizes what it is becoming. Nixera, decoding systems, architecting wealth.